Assalamualaikum warahmatullahi wabarakatuh to Dr. Ilman. So my name is Mohammad SAIFUL bin Ali and this is my group members which is Mohammad ARIFF, Mohammad FIRDAUS, Mohammad IZWAN and Mohammad Azimin. So we will do our assignment. We take the lab 3 as our topic, which is the total acid number lab. So we move to the objective.
Okay, the objective for the total acid number for lab 3 is to understand the role of the acid number as a tool to monitoring the machinery condition. So that's the objective one. And the second one is to analyze the source of the acid number on that can change on the oil sample. So that's the objective for this lab.
Introduction. So what is the total acid number or ton? Total acid number is a measure of the quantity of acidic compound present in our petrochemical sample or in our lubricant, which mean in this lab we have the 4 type of oil sample, which is our petrochemical sample or our lubricant, to do the total acid number, to find the total acid number, but we only take for the 2 types of sample oil. So a high concentration of acidic compound in a lubricant can lead to the corrosion of machine part and clog oil filter due to the formation vanish of flood. This is mean that when we get the higher value of the total acid number, which mean the corrosion is more easy to corrode the machinery part. So there is a few standardized method or ASTM that can be used to determine the total acid number, or the others method to find the ton number, which is we have a D664, we have the ASTM D974, we have ASTM 1534, and the last one is we have the D3339. But in this experiment we use the ASTM D974 for our method to find the total acidic number. So what is the ASTM D974? Is the measure of acidic constituents using a color change to indicate the inflection. The sample is dissolved into the solution of toluene, benzyl and isopropyl alcohol containing the water. So in this ASTM also there is a formula to find the total acid number, which is A minus B times M times 56.1 divided with W. So the meaning of the A, B, M and the W will be further explained in the methodology. So with this formula we can say that we can find the total acid number, and we can know the quantity of the acid in the lubricant or the oil is high or not. That's all from me.
Assalamualaikum. My name is Mohammad Arif bin Saleh. Now I will present about methodology to determine total acid number. Total acid number is determined by the amount of potassium hydroxide required to neutralize the acid in 1 gram of an oil sample. The ASTM D974 is used as a guideline and standard to measure of acidic constituent, using a color change to indicate the inflation. For preparation, treating should be prepared at toluene, isopropyl alcohol, and distilled water, which is 5 ml of toluene, 495 ml of isopropyl alcohol, and 5 ml of distilled water. Then mix all in a bottle and become a new titration solvent. Then potassium hydroxide has been poured in burette. Before start titration process for oil, titration solvent should be tested to know if has acidic content in it, which 100 ml of titration solvent add by 10 drops of phenolphthalein, and start the titration process with gently stir. End the process until ultraviolet color was appear. Then calculate the total acid number. For titration process, for new oil sample was start by add 1 ml of the titration solvent to a conical flask. Then conical flask in which 100 ml of titration solvent has been put on the weighing scale and 2 grams of new oil has been poured by using dropper. After weighing process, 10 drops of phenolphthalein were added in the conical flask. While open the valve of the burette slowly and start the process of titration drop by drop, which gently stir until ultraviolet color was appear and permanent. The milliliter of potassium hydroxide titrate calcium was recorded for the data. The step 3 until 5 was repeat for 2 grams of oil sample and record the data. Lastly, all apparatus was cleaned until after end of the process.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad by ABDUL HALIM, matric card B09181031, and I'm going to continue presenting about my group, our assessment according to title total acid number. Okay, in this experiment, the result is experiment is mainly use the visual inspection according to the neutralization of the mixture of the oil and solvent and the rate of the titrant needed to change the color. Okay, total volume of titrant needed when it's mixed with the mixture of the oil and the solvent, and when it reach the neutral, the color will change into a light purple. So this experiment will be conducted by producing the titrant drop by drop into the mixture of the oil and the solvent until the color is changing. Okay, after we get the rate of the titrant needed to neutralize the mixture, we will collect the data and then we will calculate it into a formula which is presenting at the poster. For total acid number, the unit is mg KOH over gram. First of all, we will have to find the blank sample, which is we just use the solvent and the titrant and mixture and mix it together drop by drop until we find the neutralization rate of the titrant. So for the blank sample, usually it will get 0 because the drop needed to neutralize the mixture of oil and solvent is very low, so we can assume it to 0. So in this formula, A for the volume of titrant consumed for the oil sample and the solvent, and B is volume of titrant consumed for the blank sample, which is 0. Next is M for molarity, or we call that concentration of the titrant, and lastly is weight of the oil sample, which is in the mixture of the oil and solvent. We will calculate the weight of the oil sample by using the instrument. Okay, after that we will calculate it and put the data into the formula and calculate the total acid number. Okay, through the data collected, the total acid number for the new oil is lower compared to the used oil. It's because there are a lot of contamination in the used oil, which is have burning in it, metal and other acid in this oil. So for the new oil, the total acid number will be very low compared to the used oil, but not low as the blend sample. Okay, for the mixture of the oil sample and the solvent and the oil contain the weak organic acid and strong inorganic acid, which is why in this experiment we usually use the visual inspection. So we just drop the titrant into the mixture of the oil and solvent. So the data is just calculate and measure the rate of oxidation, but not directly. We didn't know how the chemical reaction in it. We just know, but not directly calculate it. We just calculate the rate of the titrant needed to neutralize the mixture. So it merely measure the byproduct of oxidation. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Mohammad Azimin bin ABDUL. My matrix number is B0918101140, and today I'll be talking about the conclusions for our post. So for the conclusion, which is finally the lab work objective were met as students were introduced to the analysis of total acid number on samples. Furthermore, a total acid number, which is TAN, is a measure of the amount of acidic compound present in a petrochemical sample which can be new or used for. Furthermore, this method was useful in monitoring and act building in oil affected by antioxidant depletion. If the oil contains a significant concentration of acid, it can cause internal component corrosion. The amount of potassium hydroxide, which is KOH, required to neutralize the acid in 1 gram of oil sample was used to measure TAN, or which is the new oil and also the used oil. The phenometal indicator is used to indicate in acid-base titrations. If the titrations process reach a limit, or a pink color will appear and remain permanent. Changes in acid and oil can result from variety of factors, which is the acidic toxin, incorrect oils, incorrect reserve depletions, and oxidable products can cause a rise in acid concentration. The total acid number for new and used oil is 1.671 mg of potassium hydroxide per gram and 2.508 mg potassium hydroxide per gram, respectively. The purpose of blend concentration in the blend is to ensure that there are no contaminants in solvent which would react with the titrant, or to determine the quantity of the titrant that will react with the pure solvent.
Thank you.